Hey Bengals, Mrs. Hyjic here, continuing our discussion on plate tectonics. Today we're going to be talking about plate boundaries, and on your Wix you will need to make sure that you identify the different types of plate boundaries. You need to be able to describe what happens at each of those plate boundaries, as well as the crustal features that form. Now, when we talk about a plate boundary, we're really referring to the area where two lithospheric plates meet. Now, remember that the lithosphere is composed of the crust as well as the upper part of the mantle. These make up the plates. And then the lithospheric plates sit on top of a layer called the asthenosphere. And convection currents in the asthenosphere will determine the direction that the lithospheric plates, which float on top, will move. For example, if our convection currents are coming towards one another, then the plates that are floating on those convection currents will also come toward each other. If the convection currents are moving away from one another, then the plates on top will also move away from one another. So when the plates are coming together, we call those convergent boundaries. When the plates move apart, we call those divergent boundaries. And there's a third type of plate boundary, which occurs when two lithospheric plates slide past one another. Now, when we talk about plate boundaries, it's important to note that density matters. Density is going to be a very important concept that comes into play at some of these plate boundaries. So please understand that ocean plates are more dense than continental plates because they're made of a more dense material. Older ocean plates are denser than younger ocean plates. And whenever two plates come together and they are different in density, the more dense plate is going to be forced downward in a process called subduction, which we'll talk more about in just a little bit. Here's a picture of the world's tectonic plates, and you can see that the arrows indicate the direction that the plates are moving. So you should be able to identify the type of plate boundary. For example, here the two plates are moving away, so that's a divergent boundary. Here the plates are coming together, so that's a convergent boundary. And once you know the different types of crustal features that form at these boundaries, you should be able to look at a map like this and identify what types of crustal features like trenches or mountains or volcanoes or islands that might be forming at these different areas. So let's start first with convergent boundaries, which is where two lithospheric plates come together. And there's three different types of convergent boundaries depending upon the type of plates that are coming together. So the first type is going to be when two oceanic plates come together. Now remember that an older oceanic plate is more dense. So when an older oceanic plate converges with a younger oceanic plate, the more dense oceanic plate will be forced downward. And we call this downward movement of one plate subduction. And you can see the subduction right here in the illustration. So I can identify this oceanic plate as the older one because it's the one that is subducting. Now, some crustal features that form along a subduction zone include a trench, a very deep trench. Some of the deepest parts of the oceans are actually found at these trenches that form along these subduction zones. Now, when the denser plate is forced downward, it's going to begin to melt as it moves down into the very hot part of the earth. And so this additional pressure is going to force some of the magma up through the lithosphere and eventually erupt out of the crust, forming a volcano. And you can see here that on this plate, which is the younger plate, because it's the one that's not subducting, volcanic islands are forming. And so at this type of a plate boundary, you get subduction, which results in a trench, which also results in volcanoes. In this case, it's a volcanic island that's forming as those volcanoes grow large enough to come up out of the surface of the ocean. Some examples of islands that are formed at this type of a boundary is the island nation of Japan and the Aleutian Islands, which you can find off of the southwest part of Alaska. Now, the second type of convergent boundary occurs when an oceanic and a continental plate come together. The more dense oceanic plate will subduct down underneath the less dense continental plate, and you can see that here. Again, along the subduction zone, we also get a trench, very deep trench. And where there's subduction, there will be the melting of that plate, the additional pressure, which will cause magma to rise up, forming a volcano. Now here, the volcanoes form on the continental plate, so they're not going to form islands. Instead, they're going to form volcanic mountain ranges. Now, the Cascade Mountains up in the northwestern part of the United States around Oregon and Washington is an example of a volcanic island chain formed this way. And Mount St. Helens is a very popular volcano that formed as a result of this subduction. The Andes Mountains in Peru is also an example of an oceanic to continental convergent boundary where the Pacific Plate and the South American Plate are running together. So the Andes Mountains is also a volcanic mountain chain. The final type of convergent boundary is a continental to continental convergent boundary where two continental plates come together. Now the difference here is that both of these continental plates have the same density, so there will be no subduction. I know this picture is a little deceiving. It kind of seems like there's some subduction here, but there really is not. And I know there's no subduction here because there's no trenches and there's no volcanoes. No subduction equals no volcanoes. So here, when these two continental plates come together, because their density is equal, nothing is forced downward. So instead, the plates are forced upwards. They buckle upwards, creating mountains. But here the difference is that there are no volcanoes in these mountains since there was no subduction involved in the formation of these mountains. The Rocky Mountains in Nevada and Colorado are examples of mountain ranges that have formed this way, as well as the Himalayas. The Himalayas formed when the Indian Plate ran into the Eurasian Plate, causing this Himalayan mountain range, which is where Mount Everest is. And what's interesting about this mountain range is that these two boundaries are continuing to collide with one another, and the elevation of Mount Everest and other mountains within that mountain range are continuing to grow several millimeters every year. So those are the three types of convergent boundaries. Now we're going to move to divergent boundaries, which occur when lithospheric plates move away from one another. And divergent boundaries can be found both on land and in the ocean. Divergent boundaries begin on land, and let me remember to say that this is how Pangaea broke apart. When Pangaea, a huge continent, there were plates that began to move apart from one another. So one continent started moving away from another continent, creating, like here in Africa, what's known as a Great Rift Valley. And so when two plates on land start to move away from one another, a very deep depression or valley is formed. Now, if the separation continues, water will fill into the lower elevations, forming a new ocean. So Pangaea broke apart, and now we have oceans separating our continents. Now, this process continues when in the ocean, and so this is where two ocean plates separate. So this is kind of a picture that sort of shows you what happens during Pangaea, or what's happening right now in Africa. In fact, here's the land. We have two continental plates, and this plate's moving this way, and this plate's moving this way. So they're moving apart, and you can see that a valley, a rift is forming. Now, eventually it will fill up with water, forming that new ocean. Now, the two plates will continue to move apart from one another, but now they're oceanic plates moving away from one another. And right here in the middle is a crustal feature called a mid-ocean ridge that forms when the magma comes up and seeps through the crack that forms as these two plates are moving apart from one another, and that's what forms the new ocean floor. Ocean floor closest to those mid-ocean ridges, they're going to be the youngest ocean floor. And as we move away from the mid-ocean ridge, the age of the ocean floor and the density then of the ocean floor is changing. So we have older ocean floor closer to the continents here, and that's the more dense ocean plate, with the newer ocean plates and the less dense plates being found closer to these mid-ocean ridges. Now we go to our last type of boundary, known as a transform boundary, and this is where two plates slide past one another. The crustal features that form are fault lines, which just really look like cracks in the ground, and this is an aerial view of a a fault line found in California called the San Andreas Fault. You get very frequent earthquakes as a result of these transform boundaries, because anytime the plates slip, even just a small fraction of a millimeter, enormous amounts of energy is released, and shock waves will cause a lot of devastation. And you can see here in this grove of trees, where the trees used to be lined up, they're now out of alignment as a result of the fault line. And you can kind of see how the fault line runs right through this grove of trees. And then finally, we're going to talk about hot spots, which are not necessarily plate boundaries. In fact, hot spots occur in the middle of tectonic plates. They do not form at plate boundaries. And so a hot spot is just an area where magma comes up, it seeps through the crust, and it forms volcanic islands. The Hawaiian Islands and also the Galapagos Islands were formed this way. And so I'm going to let this video here explain to you what a hot spot is.
A hotspot is a localized source of high heat energy that sustains volcanism. It is not an isolated shallow magma reservoir beneath the crust, nor is it a pipe of magma that streams from the outer core. One theory holds that hotspots may begin as a blowtorch-like thermal perturbation in a zone between the liquid outer core and overlying mantle about 2,900 kilometers deep. The thermal plume allows solid, yet mobile mantle to rise very slowly and convect outward. Convection is the process by which heated material rises and cooler material sinks. Although magma may be generated as deep as 1,500 kilometers,
this is the asthenosphere right here. That's where the convection currents are. And then we have our lithosphere,
at the onset of hotspot volcanism,
which is the crust, and just this upper part of the mantle right here.
Stalls, its heat is transferred
the crust,
to adjacent
and
rock.
there's the upper part of the mantle.
This transfer
which
continues
makes
to
up
the base
lithosphere.
of the tectonic plate, where decreased pressure facilitates rock melting. The magma that forms at the base of this plate rises through the plate in a network of cracks and shallow chambers and erupts on the surface.
And so there is a volcanic island.
Over hundreds of thousands of years, large volcanoes build on top of the plate. The weight of the volcanoes bends the plate downward. Volcanoes that spent their constructive life over the thermal plume slowly get rafted away on the moving plate, and new volcanoes build in their place.
So as the
Multiple
plate
dikes
moves,
can feed several
the
volcanoes
volcano
from separate
forms
continents.
in the newer
The
area.
moving plate drags the thermal plume with it. This can explain why volcanoes can erupt again after centuries of quiescence, even after they have moved off the center of the hotspot. However, erosion greatly outpaces volcanism as eruptions wane, and the buoyant effect of the plume diminishes, allowing the volcano to subside.
All right, so guys, we've just covered the different types of plate boundaries, the 3 different types of convergent boundaries, the 2 different types of divergent boundaries, as well as transform boundaries. Now, there is a part 2 to this video that I encourage everybody to watch. It uses a pretty cool app that I found because plate boundaries are best explained through movement. And so this app shows the plate boundaries in motion. The pictures are good, but it's really hard to explain just how these plates are moving and interacting with one another and the crustal features that form using a stationary picture. So I encourage you to spend a few minutes and watch the second video. You don't have to take any notes, just enjoy it and let it be a review of the different types of plate boundaries. I'm out.